So what is the direct influence of a functional group in monosubstituted benzene? As we know that, so by electrophilic substitution reactions like nitration, sulfonation, halogenation, and alkylation, so we got monosubstituted benzene. The monosubstituted benzene further subjected to substitution reaction, we get di-substituted products. These di-substituted products, what we observe mostly, are not formed in equal amounts. That means when monosubstituted benzene is subjected further substitution, then so we get three possible di-substituted products. They are ortho, para, and meta, predominantly formed in not equal amount. Then what could be the reason? Why ortho, para, and meta products are predominantly formed in not equal amounts? So let us look into that, how the functional group has the influence in monosubstituted benzene in detail. First, I would like to discuss about, first of all, what are the monosubstituted benzene. The monosubstituted benzene are on the benzene ring. On the benzene ring, there is methyl group is present. This is called toluene. Methyl is the substituent. On the benzene, if there is NH2 group is present, then it is said to be monosubstituted. Aminobenzene is called aniline. On the benzene, there is OCH3 functional group is present, then it is called monosubstituted anisole. On the benzene, if there is OH functional group is present, then it is called phenol. And on the benzene, there is ethylene functional group is present, then it is called styrene. These are monosubstituted benzenes. Examples we can write. These are examples. Examples we can give monosubstituted. The topic is about how the substituent will influence, affect incoming another substituent, or the substituent will directing other substituent, attacking positions, ortho position, para positions, or meta positions. Simply how these functional group directing other functional group, other substituent to attack on respective position of the benzene. So based on the directing at ortho position and para position, there are, so on the benzene, ortho position is there, para position is there, ortho para directing groups. Some of the functional groups directing the substituent at ortho position, para position, we say, directing incoming group to ortho and para positions, we say. Then they are said to be ortho para directing groups, we call. So what are these ortho para directing group? There is a chlorine, there is NH2 amine functional group. Amine functional group, we can write example NH2 functional group. So chlorine, NH2 and hydroxide, one more OH. OH is the hydroxide, OH minus is the functional group, chlorine, NH2, OH. So these are the functional groups that direct other substituent to attack, where means on ortho position, para positions we say. Let us look into this ortho para directing group. One example we take for the detailed discussion. Example we say, and this example is phenol. On the benzene ring there is OH functional group is present. OH functional group is present on the benzene. This OH has oxygen, consists of 2 lone pair of electrons. So when this phenol, on this phenol, that means phenol consisting of OH functional group, this OH functional group has influence of other groups to attack on the ortho position and para position. Let us see how that OH will influence. As you know that, so OH functional group has lone pair of electrons. These lone pair of electrons, so undergoes resonance with these pi electrons. When the lone pair electrons having the resonance with these pi electrons, see, that means OH act as a electron releasing group. OH act as electron releasing group because the lone pair electrons given into the ring. So then oxygen and carbon get double bond. Then the pi electron repelling onto second carbon. Then the second carbon gets negative charge. Look at this. Since the lone pair releasing into the ring, then oxygen get the positive charge. Look at this. Oxygen get the positive charge. Carbon get the negative charge, then it is said to be carbanion. This is, so oxygen getting the positive charge, here oxygen and carbon double bond. When the negative charge is present on this carbon, the electrophile reagent attacks. Then ortho compound we get, ortho compound is formed. But the electrophile is not approaching this carbanion, then this negative charge move inside into the ring and causing repulsion of these pi electrons. Then the pi electrons will move on to this fourth carbon, then para position, this is said to be para position, we say, para position. And when the electrons, when the pi electrons are localized on the fourth carbon, carbanion, if the electrophile attack this carbon, then we get the para compound. We can get the para compound. Agar in case the electrophile not attacking this fourth carbanion, then this negative charge again go inside into the ring, negative charge go inside. When the negative charge go inside, so then pi electrons get repulsion, then again the negative charge localized on the next carbon, carbanion. So then this is also ortho position. Again the reagent attack, electrophile reagent attack on this ortho position, then will give ortho compound. In case the electrophile not approaching this carbon, then again this negative charge go into the ring. Then the pi electrons present between the oxygen and carbon will move onto this oxygen again to the original place. Then we can get the phenol. Phenol is again we can get. So what we understand from this is that when the benzene is attached to the substituent or to the functional group containing the electrons lone pair, and those lone pair of electrons will interact with the pi bond and triggering the resonance, delocalization of electrons. As a result of this delocalization, electrons are moving onto the ortho carbon, para carbon, So at this time, the reagent, electrophile reagent will attack and will give the ortho product and para product. So not only hydroxyl group but also chlorine. Chlorine is the function, means substituent NH2 OH minus or NH2 NHR NHCO CH3 OCH3 CH3 alkyl group also and C2H5 also example for the orthopara directing groups we say. Okay, now in case of alkyl halides, halogens, moderately deactivating because of their strong negative ion effect, overall electron density on benzene ring decreases. It makes further substitution difficult. See, the chlorine is present on the benzene as a substituent, releasing electrons into the ring and making ortho position more negative, para position more negative. So then we can get ortho para. This is ortho. This is para compounds we can get. Two products we can get. One more, again ortho position also. The chlorine also having that electron releasing property. Electron releasing property we say. Now, another one is, so the second type of groups that are present on the benzene, monosubstituted benzene are meta-directing groups we call. This is meta-directing groups we say. What are the meta-directing group? The groups which direct the incoming group to meta position NO2, cyanide, aldehyde, carboxylic group, SO3H group comes under meta-directing groups. The overall electron density of benzene ring decreases because of this further substitution. That means if the benzene having that NO2 group, carboxylic group and SO3H group, definitely the electron density in the benzene ring decreases. Electron density in the benzene ring. So hence these are said to be electron withdrawing groups also. What we call these electron withdrawing groups. That means the electron density on para ortho position comparatively is less than the meta position. That means in the meta position is the meta position having more electron density than the incoming electrophile attack at the meta position. Since electron density is more, negative charge is more, or pi electrons are present. So then NO2, cyanide, CHO, COOH are said to be meta-directing groups we call meta-directing groups, and so these are said to be deactivating groups we say, deactivating groups. The electrophile attacks are comparatively on electron-rich meta position. Note this point. Electron-rich meta position we say. So let us look into this compound. What we call this is nitrobenzene NO2. Between nitrogen and oxygen there is a double bond. There is a coordination covalent bond. Here oxygen consisting of how many? 1, 6, 8. Now this is the NO2 structure. Since there is a pi bond resonates with this lone pair, then this pi bond moving on to this oxygen. This pi bond is moving on to this oxygen. When oxygen gets negative, nitrogen gets the positive charge. This is the polarization of the pi bond. When nitrogen gets positive charge, the pi bond present between this So in the benzene ring, move between this nitrogen and carbon. Then here double bond is formed here between nitrogen and carbon. Since the pi electrons are coming out, from the ring, so then the ring is deactivated, or ring will have deficient of electrons, then the positive charge appear on the carbon. The positive charge appear on the second carbon, that means ortho position. But on this meta position, there is a pi electrons are there, electron density is there, then electrophile approaches this meta position, because electrophile has the positive charge. The nucleophile attack at this ortho position. Look at this. Electrophile approaches onto this meta position. This is the position because pi electrons are present here. In case electrophile not approaching this meta position, what happens? There is resonance. Electrons will move on to this. These pi electrons will move to the positive charge. Then the positive charge shift will be from ortho position to para position. So again the pi electrons move to this para position. Then again the positive charge is produced here, transferred to the ortho place. Here is the positive charge. Again the pi bond present in the outside will come into the ring. Then nitrogen get the positive charge here. Oxygen get the negative charge, means electrons come back. Then we'll get the normal structure. We get the normal structure. So electrons again coming back. Then this pi bond will move back. The normal structure will get. That means here what we understand from this resonance of the electrons, delocalization of electrons, is that electron density is present, electron density more at meta position. Here is the meta position. Due to this NO2 group, due to this carboxylic group, due to this sulfonic group, due to this aldehyde functional group, electron density at the meta position is more, hence, and this is meta directing group, we say. These are called meta directing meta directing groups, we call. Deactivating the benzene ring. So with this, what we can understand, once the benzene is substituted with the functional group, that functional group will determine the incoming substitution.